find traces of life in our solar system. There are many different kinds of satellites and planets where life is likely to exist. However, the presence of oxygen, liquid, and gas is one of the conditions under which life can exist, so it is important to find celestial bodies with those conditions. First of all, oxygen is one of the basic elements that life needs, and it is difficult for life to survive in an environment where oxygen is not present. In particular, in the case of liquids, it is important to have water that can be the basis of life, and in the solar system, several planets and satellites, including Earth, are equipped with water, so life is likely to exist. Therefore, finding celestial bodies with these conditions is one of the important goals of space exploration. Among the planets and satellites discovered so far, studies suggest that life is likely to exist in Pluto's Charon, Saturn's Europa, and pre-Pluto's Kepler 22b, in addition to the oxygen and water-equipped Earth. Titan is one of the largest satellites in the solar system and the second largest among Saturn's 53 satellites. Titan is similar in size to Earth, and it is one of the only celestial bodies outside the Earth to have an atmosphere. Unlike the Earth's atmosphere, this atmosphere is made up of nitrogen and methane. Due to its high pressure and temperature, Titan's atmosphere contains liquid methane and ethylene, and solid hydrocarbons. These atmospheric and surface environments are very different from those of the Earth. However, this unusual environment has raised the possibility of life in Titan. Theoretically, in Titan, compounds such as methane and ethylene can be energy sources for life instead of hydrogen and oxygen used by life in environments like Earth. However, so far, there is no evidence that life has been found in Titan, and reports that life has been found outside of Earth are not true. However, Titan is one of the most likely objects to be found, and continuous research is being conducted. Jupiter is one of the largest planets in the solar system, and it has many large satellites. Among them, Jupiter's representative satellites, Europe, Ganymede, and Callisto, have their respective characteristics, and are being studied to see if there is a possibility of life. Europe looks like a simple watery satellite from the outside, but it is assumed that there is a large saline seabed inside. The seabed may have environments where life can survive under Earth-like conditions, and although there is no oxygen in Europe's atmosphere, it is known to consist of ice and water vapor. Ganymede and Callisto are the largest satellites on Jupiter, with surfaces similar to Earth's moon. There is no oxygen in their atmosphere, but water has been found in the crust of Ganymede and Callisto. There is a possibility that life exists in the crust and seabed of these satellites, but further research is needed to confirm this. Therefore, it is not yet clear whether there is a possibility of life on Jupiter's satellite. However, by studying the geological properties and atmosphere of these satellites, it can be of great help in identifying where life is likely to exist in space. The asteroid belt is a collection of small celestial bodies located in the space between planets in our solar system. The reason is that the asteroid belt is small in size, lacking in quality, and is generally not suitable for living things that have to survive in extreme conditions such as high temperatures or extreme cold. In addition, the asteroid belt is a very large area in space, and it is very difficult to observe through spaceships and satellites, and very detailed and sophisticated investigations are needed to determine the existence of life. Therefore, it is considered very unlikely that life exists in the asteroid belt. However, the asteroid belt is believed to have played an important role in the creation of life on Earth due to the collision and mixing of early extraterrestrial materials in the solar system. These studies can show the history of asteroid belt's origins in space life, and can provide important information for the exploration of life in space and the study of its origins.